Hi there, welcome. This is a three-part series on factoring. This is part 3. So if you haven't watched part 1 and 2, make sure that you go back and make sure that you're practicing the problems in between. It's really important as you get through these that you're practicing what you're learning in these videos. This is part 3. It's about factoring trinomials with any leading coefficient. And before we did leading coefficient of 1, and now we're going to talk about any leading coefficient. The process is pretty much the same. Before, you just, the x part didn't have a number in front of it. And that's really important because we are going to start seeing things with numbers in front, not just an x squared, but like 3x squared or 4x squared. And so you're going to learn how to factor any trinomial, and here's one of the examples we're probably going to do today. So remember, factoring is essentially just writing the same thing, but in a different form. And again, here's what I mean by that. So if I had a table of values that were already filled out, I'd want to pull out common factors. Go ahead and pause the video real quick and try factoring this. Okay, so hopefully you've had a moment to try and factor this. Find common factors. So when I look here, this is a really intense problem because there's lots that could come out. What are common factors among 10 and -4? Well, to me, it's only the number 2. But then there's also x's. So there's 2 x's here, and there's 1 x there, so I guess I can pull out an x as well, which means I'm left over with -2. So -2 times 2x is -4x. So what would this have to be 14? Well, it's got to be negative times a negative makes a positive, so it's got to be negative something, and it turns out to be -7. -7 times something, -7 times something gives me -35, or maybe even easier, something times 2 is 10x. Something times 2x is 10x. Well, that something's got to be 5x. So to write this in factored form, we would say, oh, it's 5x minus 2 times 2x minus 7. And the standard form is just the result of multiplication. And so we can pull out like terms. So we've got 10x squared, 10x squared, and we've got -4 and -35, that's -39x, so -39x, and 14 comes out, so and 14. So these two forms come from the same information on the inside. One is called standard form, the other is factored form, and they reveal different things when we go to graph them. So here, if I had more time in class, we'd really explore this. And I talked a little bit about it in the past video, but the number one most important thing to know is that the diagonals multiply to the same thing every single time. And if you don't believe me, pull out a calculator and check for yourself. Something important to know is that if I take -4x and -35x and I multiply them together, -4 times -35 is -140x. And same thing, I'm going to use a different color so that you can see the difference between the crossings. If I multiply 10x squared and 14x, or just 14, I would end up with 140x squared. So notice, see, this would be positive. This would be positive. 140x squared and 140x squared. Take your time, explore this. This is a core idea. The diagonals always have to multiply to the same thing every time. Write this down. I'm going to prove it to you here. So here's a generic form that I want you to see. Instead of using numbers, I'm going to use letters. So I'm going to show you. And we're going to actually just do it multiplication. So if the format is ax plus b, this is a binomial times a generic binomial, cx plus d. And I'm just using letters instead of numbers. So we've got ax plus b and cx plus d. Ax times cx is a times cx squared. And b times cx is b times cx. And ax times d is a times dx. and b times d is b times d. Now, I'm going to check the diagonals. Do the diagonals multiply the same thing? Well, this is going to be a times c times x squared times b times d. Well, I can just rearrange those, and those equal a times b times c times d x squared. I just took a times b times c times d and then x squared. I just reorganized. And we're going to do it for the other diagonal. It's going to be b times cx, b times cx times a times dx. Okay? And again, we're just going to reorganize. I have a times b times c times d. A times b times c times d. And then I've got an x times x. Well, x times x is x squared. I hope that you see that the result of the diagonals is exactly the same. Okay, so we're going to practice factoring these, and I've created something called a diamond problem. You might remember seeing them a while ago in class. Maybe not, no worries. It's just a tool to help us organize some of our thinking throughout this activity. So remember, the first number is going to go into the top box. We've got 3x squared and 8. And these two are going to have, so we need something that multiplies the diagonal, well, 3 times 8. We need something that has a multiplication of 24, because 3 times 8 is 24, so something that multiplies to 24, and this is going to multiply to 24, but remember that if it's reverse multiplication, this is also going to add up to 10. So it has to add to 10 and multiply to 24. Well, this is great. Now I'm just going to make a list of values, things that multiply to 24. So we've got 1 and 24 and 2 and 12 and 3 and 8. We've got 4 and 6, and I could keep going, but we don't need them because I think we've covered all of our bases. So this adds up to 25. Nope. 2 plus 12 adds up to 14. Nope, we need 10. 8 plus 3 is 11. Nope. Okay. 4 plus 6 is 10. Yes. 4 plus 6, they multiply to 24, and they add to 10. Okay, so we've got our values for the diagonal. Now I need to erase some of this stuff because I got excited here. Okay, so we're going to erase these diagonals, and I'll rewrite the things that I need to. So 3x squared and 8. And we know that one of the values is going to be 4, and the other value is going to be 6x, and the diagonals multiply to be the same thing. This main diagonal here adds up to 10, which it needs to make it equivalent. And we're just going to pull out common factors. So what's common among 3x squared and 4x is just an x. Which makes this have to be 4, because 4 times x is 4x. Make this have to be 2. Which means this has to be 3x. So my factored form is 3x plus 4 times x plus 2. It's the same thing, just written in a different format. We've got another couple of examples for you. Again, I'm going to go a little bit faster here. We've got our 2x squared and our 6, and we know that it has to add up to 7x. So we need something that multiplies to 12 that adds to 7. Well, what are multiples of 12? We've got 1 and 12, we've got 2 and 6, we've got 3 and 4. This is 13, this is 8, this is 7. Perfect. So 3 and 4 multiply to 12 and add to 7. So we've got 3x and 4x, and we're looking for common factors. Common factor among 2x squared and 4x is going to be 2x, which means this has to be just 2. And 2 times something is 6, well, that's got to be 3. And 3 times something is 3x, it's got to be x. So our factored form here is, we'll write it in the same place we did before so it doesn't confuse you, x plus 2 times 2x plus 3. And if you don't believe me, remultiply it out and see that these are actually equivalent to one another. They're just written in a different format. This is the last one we're going to do together, and I chose it because it has negative numbers in it, and I really want you to see that. So again, we're going to do our setup, 4x squared and negative 15, and they're going to have to add, the diagonal is going to have to add up to 17x, which means that we're going to add to 17. And to check, what do we have to multiply to? Well, we have to multiply 4 and negative 15. Well, 4 times negative 15 is negative 60. So we're going to put negative 60 as the thing that we have to multiply to. So in order to do that, I'm going to make a really long list. Negative 60, two numbers that multiply to negative 60. We've got to find one of them that adds to 17. So let's try, let's get started with the basic ones. 1 and 60, negative 1 and 60. Negative 2 and 30. Negative 3 and 20, negative 4 and 15, negative 5 and 12, negative 6 and 10, negative 10 and 6, negative 12 and 5, we've got negative 15 and 4, and we've got negative 20 and 3, and negative 30 and 2, and negative 60 and 1. All we need of all of these is just one of them to add up to positive 17. And I'm going to start at the top because I've got a low negative number and a big positive number, which is going to make it positive. So this doesn't work out. That's 59. We've got 28. We've got, oh, hey, look, we could have probably stopped a lot sooner had I recognized that that was 17. So one of the numbers is negative 3, the other number is 20. Once you find one, you don't have to keep going. We've got negative 3 and 20. And we're going to find common factors. So a common factor of 4x squared and 20 is 4, which makes this got to be 5 times 4 is 20. 5 times negative 3 is 15. And, oh my goodness, I made a big mistake. This should be 20x, which means the common factor here is going to be 4x. 4x. And that's still 5 and negative 3. And then this is x as well. So our factored form is x plus 5 times 4x minus 3. X plus 5 times 4x minus 3. I know this video has been long, but there's a chance for you to practice using the video. Pause here, try these. I'm going to show you how to do them in a moment. Or I'm going to actually just show you the answers in just a moment. Hopefully you've had a couple of moments to try these. Let's check out some of the answers for them. If you factor these, you should get the factored form should be 3x x plus 3 times x plus 6, and for the second one, x minus 1 times 2x minus 3. And if you need have questions, please do ask your teacher during your class meetings how they got this answer. If you would like to see the procedure for how these happened, it's always helpful to have a couple of problems on hand so that you can check your work with the teacher when it comes time. All right, try the last activity for this week. Review this video if you get stuck or have questions. This can be challenging and it takes a long time to get. Be sure that you're attending your teacher's office hours, their Zoom office hours this week, or email them if you have any questions. We're here to help. We know these are strange times and we want to help you as best we can. Don't get frustrated. Please do email us. These problems take a long time to do, especially at first. I've done them for years and I've had lots and lots of practice. As you practice more, you will get better. So be patient with yourself. Ask a friend who's had class, or ask a sibling if you have a sibling, or email your teacher, or come to our Zoom office hours. We're really here to help you. Good luck, and please don't hesitate to reach out if you need help.